Hi, in this lesson, we're going to look at how objects are created and stored. Let's go. In the last lesson, we learned that a class is a template for creating an object. A class is a template that holds information about what the class object's state and behavior can be, and how objects can be used in programs. In the rectangle class that we used in the last lesson, we declared that every rectangle must have a width and height, and can compute area and perimeter. A rectangle cannot be created unless it has a width and a height, and will always be able to compute the area and the perimeter. But what exactly does this look like in Java? This is what the actual implementation of the rectangle class looks like. There is a lot going on here, so we are going to break this down so it's easier for us to understand. Let's first start by examining this segment of code. The first part of writing a class is writing a class name. Just as we had to create a skeleton for my program, the rectangle class is created by establishing the name and enclosing all of the content of that class in curly brackets. Each class should be written in its own Java file and given the name of the class. The Java file for the rectangle class would be called rectangle.java. The second component in the creation of a rectangle class is establishing the instance variables. Instance variables are used to store the state or data of the object instances. Whenever a new object is created, it will store its values in the instance variables. In this case, the instance variables are the integer values width and height. We can think about instance variables as the basis of the class template. The variables that are required to create an object make up the instance variables. We write instance variables with the keyword private at the beginning so that the variables cannot be accessed outside of a class file. We will learn more about this in future lessons. It's important to note that this declares the instance variables, but does not initialize them with values. This will happen when the object is created. Once the instance variables are established, the next part of creating a class is creating the constructor. The constructor, or signature of a class, allows for the creation of a new rectangle object. The first piece of the constructor is the constructor name, which is what will be used to create a new rectangle object. The name of the constructor must match the name of the class. The second is the parameter list. The parameter list lists the type of variables that can be passed into the constructor and their variable names. The variable names should be written in the standard lower camel case that we've previously used for naming variables, and should not be the same as the instance variable names. These are often referred to as formal parameters. Formal parameters must be given a type so as to indicate to the constructor what types of values should be passed into the constructor. If one of the formal parameters does not specify the variable type, the program will cause an error, expecting an identifier. An important thing to note for future reference is that the constructor does not have a return type. We will learn more about this in future lessons, but know that the constructor is different than the other behaviors that are found in a class. Now that we've created a rectangle constructor, we can use it to create rectangle objects. This is the standard format for writing a new object. We will dive into what each part means. Just as we needed to declare a new variable with a value type, objects need to be declared the same way. In this case, because we want to create a rectangle with the rectangle class, we need to declare that this variable is going to be of type rectangle. Rect1 here is the object name. Whenever we refer to this object in the future, we will use the name that we've assigned it. This is the same as with primitive variables. While the left side of the assignment is fairly similar to declaring primitive variables, the right side of the assignment is what is substantially different for reference type variables. The first big difference is the use of the new operator. In order to create an object, we must use the new operator to instantiate a new class object. Instantiation is the process of creating an instance of an object, which allocates memory for a new object and references that object in memory. The new operator allows us to create a new object by making a call to the constructor. The name of the constructor needs to be the same as the name of the class. The call to the constructor contains two components, the constructor name and the actual parameters. The actual parameters are the actual values that are being input into the constructor. The actual parameters that are being input into the constructor are passed using call by value into the formal parameters that were established when the constructor was created. Call by value means that the value being held by the variable is copied to the formal parameters, instead of the actual parameters themselves being used in the constructor. For example, if the constructor was rectangle, value 1, value 2, value 1 and value 2 are not directly used in the constructor, but a copy of their values would be. This initializes the formal parameters with copies of the actual parameters, which can then be used in the rest of the constructor. The formal parameters rect width and rect height now hold the values of 14 and 16. When the variable names rect width and rect height are used in the constructor, they will continue to hold those values until they are assigned something else within the program itself. The formal parameters are often used to initialize the instance variables that are declared within the class. In this case, the variables width and height are now being assigned the values of rect width and rect height, which are 14 and 16 respectively. The actual parameters that are input into the constructor must match the types that are declared for the formal parameters. In this case, because 14 is wrapped in quotations, it is actually a string data type. The program throws an error because the actual parameter 14 that is input to the constructor doesn't match the expected input. If the types do not match exactly, then there will be an error in the program. The actual parameters that are input into the constructor must also match the total number of parameters that are found in the constructor. Otherwise, there will be an error. Now that we've learned about constructors, let's try to make one on our own. Let's say we wanted to create a student class to keep track of all the students in our school. A student has the attributes name, grade level, and GPA. The constructor of the student class will initialize each of these attribute variables with a value. The first step in creating the constructor is determining what the instance variables or attributes of the class are going to be. Before moving on, can you figure out what the instance variables for this class should be? The student class has the attributes name, grade, and GPA. The instance variables for this class should match those attributes. The name variable should be a string, so we can use characters to determine the student's name. The grade level should be an int, and the GPA should be a double, as we will need decimal values to determine a student's GPA. Now that we have the instance variables, let's try to write out the constructor. For the student class, the constructor should initialize each of the instance variables with a value. Try writing this out before moving on. Here is the constructor for the student class. As we learned earlier, the constructor name must match the name of the class and needs to start with the keyword public. The constructor should take 3 input values, a string, an int, and a double. Here we have named each formal parameter, the name, the grade, and the GPA. Each includes the data type. Because this constructor initializes each of the instance variables, we have to set the value of the instance variables to the formal parameters that are going to be input. Now that you've learned about creating and storing objects, let's get some practice using them in the CodeHS editor.